Thank you, Diana, and Svitla for the invitation. I really appreciate you're giving me the opportunity to share my ideas, my thoughts about what we're going to see. And like Diana said, if you have questions, just write them. I prefer to answer the questions while I'm talking, because in that way I will have some feedback of what I'm saying, if you understand or if you agree or not. And if you don't agree, please let me know. I prefer people that have a critical thinking and does not agree with what I'm saying, that people that agrees. Yeah, when you have this conversation, sometimes you learn something. So I'm going to talk about 5 design heuristics to rule them all. This is like a summary of a class that I teach. I've been teaching for a long time, more than 10, 12 years, but in Spanish. So this is the second time I'm going to talk about this in English. The first time was last year in the Canaries in a SoccerCan conference. So, if you have questions again, just let me know. A little bit about myself. I'm 35 years happily programming. Yeah, it looks like a lot of time, and it is. I made the numbers last week when I gave a talk at the Nerdiarla conference, and I couldn't believe it. But I'm also the founder of 10 Pines. 10 Pines is the company where I work and where I teach these things. Also, I founded a foundation of Smalltalk in Argentina, because I love the Smalltalk language. I'm also a professor at the University of Buenos Aires, but if I have to define myself, I think I'm a passionate programmer. At least I try to do it with passion. And I know I have to change that picture. It doesn't look like me anymore. Anyway, so what I want to talk about first is just to define or to challenge the idea of principles and rules or design rules. And so the principle word is used or have been used a lot in our community. So that's why I want to challenge it a little bit. So what is a principle? A principle is a fundamental truth or proposition that serves as the foundation for a system of belief or behavior or for a chain of reasoning. That's what the Oxford Dictionary says. And the important thing here is that a principle is a fundamental truth. It's something that is always true, and that you use it as a foundation for what you think about using that principle. What's a heuristic? A heuristic is, well, there are different definitions, but we can say that it's a mental shortcut that allows people to solve problems, make judgments quickly and efficiently. This rule of thumbs strategy shorten decision-making time and allow people to function without constantly stopping to think about their next course of action. That's basically the common definition of heuristic. But I like to think in our context as a heuristic, as a rule that must be contextually analyzed. So it's like a rule or a principle that is not always valid, and you have to analyze it, and you have to think about it every time, or most of the time you use it. Therefore, it may have exceptions, and it's not always convenient to use it. There is a question. I have a question about presentation. We have the documents. Yeah, of course. Yeah, I can share you the presentation at the end. And this is the main question of this beginning of the presentation, and is are the solid principles or rules? Because that's the most common design guidelines that we use sometimes, and that we use when we program with object-oriented, in the object-oriented paradigm. So let's see what Bob Martin, Uncle Bob, has to say about this. And he said, the solid principles are not rules. They are not laws. They are not perfect truth. They are statements on the order of an apple a day keeps the doctor away. This is a good principle. It is a good advice, but it's not a pure truth, nor is it a rule. So he wrote this, I think, around 2000, 12, I don't remember exactly. There you have the URL. But there has been a lot of, discussion about the solid principles and if they are principles or not. And finally, Bob Martin had to say that they were not principles and that in fact, these principles are heuristics, which is a contradiction because if it is a heuristic, it cannot be a principle and the other way around. But anyway, he says that they are common sense solutions to common problems. They are common sense disciplines that can help you stay on the out of the trouble. But like any heuristic, they are empirical in nature. They have been observed to work in many cases, but they are not proof. There is no proof that they always work, nor any proof that they should always be followed. So anyway, we're going to talk about heuristics, not principles, and beware when you read or hear somebody talking about principles or rules when we talk about design, object-oriented design or software design. Of course, I'm really a critical person. I like to, I don't know why, but maybe it's my the university where I went, or I don't know why, but I like to ask questions all the time. So I have questions about this, and one of them is if they are heuristics, why did he call them principles? And did he know from the beginning that they were heuristic and not principles? I think that's a questions that I'm not gonna give you an answer for that, but I think there are questions that it's interesting to think about. So we're going to talk about heuristics because we don't care about marketing nor dogmatic thinking. Okay, we want you to think critically, and that's why we want to talk about heuristics. We want you to think about the application of this heuristic every time you think you need them. Before I start talking about heuristic, I'm going to talk a little bit about some conceptual definitions, and I'm going to start with the beginning with the definition of software. What software is, or what is the definition of software I'm going to use during this talk, okay? Because there are many definitions of software, and the one I'm going to use is this one that says that software is knowledge expressed in a computable model of a problem domain of reality. Basically, what I'm trying to show you here, or the most important part of this, that software is a model. When we are developing software, we are creating a model, not any kind of model, a computable model, and that model represents the knowledge you have about the problem you're solving, okay? So I like to think of software this way because it allows you to understand many things, many problems we have when developing software. There are many other definitions of software. One of them, for example, is that software is a set of instructions that you give to a machine, and it's fine. It's also a definition of software, but the problem with that definition is that it doesn't allow you to think in important terms regarding design, okay? I'm putting there Alonso Church because Alonso Church was the creator of lambda calculus, and lambda calculus. When you think about lambda calculus, it's like a model, okay, that you are creating of what you're representing in that case. So if we have to draw a picture of what I'm saying, we have a reality. If we could, put a limit to reality, which is absurd, but anyway, it would be like all, yeah. And then we have the problem domain, that's the thing that we have to solve, and we have the model that is the software. And what we have is every entity that we have in the domain, we want to represent that with an object when designing with object-oriented paradigm, okay? That's basically what we think about software. It's a model, and there are many differences between the problem domain and that model. First of all, the problem domain is an arbitrary definition. It is defined in natural language, English, Spanish, French, or whatever. It is ambiguous and contextual. When you talk, you always use the context to reference things that you don't see, that you don't say, that you don't explicitly say, okay? But the model is almost the opposite because it is expressed in a formal language, a programming language, a formal language. It is executable, And that model is expressed in the source code. I'm not going to talk too much about that idea, but for me, the design is the source code. That's an idea, an old idea that was written by, I don't remember the name of this guy, that wrote a paper about what is software design. Yeah, Jack Reeves. Thank you, Ezequiel. Around 1994. Okay, and I recommend you to read that paper. So there are many questions we have, or we can make ourselves about this definition. For example, why do we model? What language do we use to model? What type of model we do, and so on. It's an interesting topic. And the most interesting thing is that there are many other professions that also model, like physics, biology, chemistry, math. And what we can do is that we can take ideas from them and start doing the same things they do that we think they're good or valuable. And then we don't have to create new ideas or new ways of modeling. That's why it is also interesting to think about the software as a model. And a good question to make ourselves is, if software is a model, what is good software? Because we are here because we want to write good software at the end. We want to have software that is maintainable, that is understandable, that does what we want it to do, and so on. So under this definition, good software is a good model. Okay, it is simple as that. Of course, we have to define what is a good model from the point of view of software. And just very quickly, what I'm going to say is that when you're talking about a good computable model, there are three different axes that you have to care about. That is the implementation, how it executes, the descriptive axis that has to do with the artistic part of our profession. Yeah, that's the way we write the source code. How understandable is that if we use descriptive names for the objects or not, and so on. And then there is the functional axis, that is how good is the representation of the domain. So there's three different axes that we have to care about for our model to be good. I'm going to talk about the functional axis most of the time on this talk. So let's say we agree, at least for this hour and a half, on this definition. Let's say we agree that software is a computable model. So the following question we have to ask ourselves is, okay, how do we create that model? At the end, what is software development? And again, our profession is very young. There are many definitions and idea about what is software development, but the way, or at least the way I like to think about software development, is as a learning process. A learning process where you understand something and you represent that in the model. Okay, and it's like all learning processes as a iterative and incremental process. And I also like to think it as a learning process because at the end, the software is representing your idea about the problem domain. Okay, it's knowledge that represents what you think about the problem domain. So how to create usually a model? Definitely it's not the same way as we create a car or we build a house. So when we use those analogies, like developing software is like building a house. Let's call this architecture. Well, it's not sometimes a good idea to do those analogies, but the way we make a model grow is we have the problem, we make an observation on the problem domain. Let's say we see that entity, $1, we create a mental model for that observation that we project to our computable model, in this case, the program, and that allows us to reflect on what we did, to understand a little bit better the problem domain, because that model is expressed in a formal language. Okay, it's not expressed in natural language anymore. It's expressed in a formal language that also has to execute. Okay, that's an interesting trait of the software. And then that allows us to learn more about the problem domain. And this is a continuous feedback between the domain and the model. We're in a continuous iterative and incremental process of learning when developing software. So at the end, it's like a formalization of knowledge. It's a process where we formalize knowledge that is expressed in a natural language, and we have to express in a formal language, okay? For sure, you may be asking yourself, what is this guy doing? what this has to do with creating a UI with React, or writing a mobile app and so on. So yeah, I understand those questions, and the thing is, at the end, even though if you're writing a UI with React or whatever you're doing, you are modeling something of the domain. In the case of a user interface, there is a domain problem that has to do with how you present information to a user, to a human, and what's the best way to do it, and so on and so on. The thing is that sometimes those problems are solved by frameworks, like, for example, React, and you only have to use it. But that doesn't mean that you are not modeling anymore, okay? But let's think about this. Let's say that, okay, we agree on that too, that creating developing software is like a learning process. So there's a key feature when developing software, and that is that the time passes, okay? The time passes when we learn. Like I said, it's an iterative and incremental process, and the time passes when we have to share the information, the knowledge that we have about that problem that is expressed in our software, in our source code. That's why our source code is the ultimate source of truth from the knowledge point of view of what we are representing. See, it's not documents. They are not the documents. They're not the the documents that we usually write. The source code is the real documentation of what we understand of the problem, and we have to share that with the people that we write the program or the system. So one interesting idea that we have to deduce from this is that we want our models to teach us, because they are models and they represent knowledge. So we want to write our models in such a way that I don't have to go to a different document or to a different place to know how to use it, to know what it represents. We have to write our models in such a way that they will teach us how to use them, or how they change, and so on. So, in summary, software development is an iterative and incremental process. We organize our knowledge in different ways, and we also create knowledge based on concrete facts, and from the facts we go to generalizations and so on. I'm not going to talk about these last two things, but just to give you an idea of what I think and we think about software development. So, now the heuristics. I don't know if there is a question. Let me see. In math or physics, which is how close mathematical model to the model as we define it in this talk. Okay, so mathematical models are not computables, are descriptive models. So they are models, but not the same kind of models. Physical models also are descriptive models, for example, not computable. And one of the main differences between the models of physicists or mathematician and so on is that they model things that are defined, let's say, by nature. But we, as software development, have to model things that are defined but by the same humans. That's why I said they are arbitrary. So we have to model what a bank is, what a hospital is, I don't know, what a financial instrument is, that are all definitions made by humans. Even though, for example, we have to create a computable model of the relativity theory created by Einstein, it is a theory created by a human. So we are not modeling the real physics, but we are modeling what somebody thinks about nature, okay? We have mathematical model and so on, but are descriptive, they're not computable. And the difference is that descriptive models, they only talk about the what, and computable models talk about the what and implement the how. That's the main difference. There's a very, very interesting video about this. Is for sure you know Sussman and Abelson. They were professors at the MIT, and they recorded a class they taught at 1986, I think, the moment Argentina won the World Cup in Mexico, and the first lesson given by Abelson, the first 4 minutes, he talks about this, and it's a great explanation. So if you have time and you like to see those kind of videos, just look for Sussman and Abelson, and I recommend you to watch the first 5 minutes, and that would be great. You will like it. Good. So I love the idea of being self. Okay, great. Thank you, Alan. So now the heuristics. Okay. The first heuristic that we're going to talk is that for each entity in the problem domain, there must be an object that represents it faithfully. It's kind of difficult to understand, but basically what we're saying is that if you see something in the problem domain, an entity, you have to have an object that represents that faithfully. What I mean by faithfully, it means that the messages that the object is going to answer should represent the essence of that entity that we are looking in the problem domain. Okay, so for example, let's say we are modeling the Gregorian calendar. Calendars are really good for modeling. Of course, a calendar is also a model, like I said, with the relativity theory of Einstein. But for example, the Gregorian calendar is a model that was created by the Pope Gregory, I don't remember the number, that tries to explain, or at least to represent, how the time passes. Okay, each calendars do that. So we have different types of calendars based on different cultures, and so when we have to write a software about a calendar, what we're doing is we're modeling a model that somebody created to understand how the time passes. So let's say we have to model the Gregorian calendar, and we have to represent December 25th or January 1st. So how do we do that in languages like, let's say, JavaScript? So I would like to have some abstraction, some class that will allow me to create something that is not really a date. Because if we think about it, December 25th is not a date. December 25th of the year 2024 is a date. But December 25th, it is not, because it doesn't have a year. But we can talk about December 25th. We have an observation, and we can talk about, in the problem domain, and we can talk about December 25th or January 1st. So if we can talk about those things, we can think about those things. So that means that they exist in the problem domain, and then we should model them with an object. So in JavaScript, there is no way to do that. Okay, the only abstraction JavaScript gives us to represent elements of the Gregorian calendar is a date, is the class date. And a class date, you have to create it with a year, a month, and a day number. So let's say we call this Christmas, and now what I'm going to do is console, a very simple thing. I'm gonna print that on the screen, on the console. Okay, and well, here it happened a lot of things. The first thing that we can see, okay, is that we cannot have just something to represent December 25th. December 25th is not a date; it's a day month, or a day month, a day of a month that has no year, like I said. So in JavaScript, you don't have the possibility to represent a day of month. You have to have all dates, and in reality, dates in JavaScript are not dates, are timestamps, or dates with times, okay, because it has also hours, minutes, seconds. And an interesting thing about this model on how representing dates in JavaScript is that it doesn't do what you expect, at least from my point of view, because if I want to create December 25th of 2024, I would think that the month that I have to use is 12 because December is related with the number 12. But if you do that, in reality, what's going to happen is that that month that is 12 is not going to be December, but it's going to be the next month. Yes, and in this case, because it is December, it's going to be the next month of the next year. So month in JavaScript are 0-based and not 1-based as the Gregorian calendar. So if I want to represent Christmas of 2024, I should use 11 as a month. So what I'm trying to tell you, to show you here, is that we do not only lack the abstraction to represent a day of month, also the how we represent dates is not how we do it in the problem domain. Okay, it's something that doesn't work, that generates some cognitive problems, and in this case, it has to do with the number of the month. How do we do that in Java? Well, in Java, after version 1.8, there's a new model of the Gregorian calendar called, well, I don't remember the name of the package, but there you have an abstraction that is month day, that allows you to represent just a month with a day. And if you try to get the year from there, there's no way, because you don't have year. It's just month day, okay? And therefore you can represent December, Christmas, or you can represent New Year, or whatever, that are ideas that you can talk about, things that you can talk about without a year related to it. Another example of this is the idea of representing a credit card. Let's say we want to create an object that represents a credit card. So a credit card knows its owner, its number, and its expiration date. Let's say that's what a credit card is. So a good question is, how do we represent an expiration date? Is really a date the expiration date of a credit card? So if you think a little bit about it, you will notice that not. You know, an expiration date is not a date, even though we use the word date. Okay, but an expiration date is really a month of a year. So if we want to represent credit cards, we will have to have something that, okay, the owner name, the number, and the expiration date. That is not a date, that is a year month. Okay, in Java, we have that abstraction, year month. That abstraction doesn't exist on JavaScript, nor Ruby, nor PHP, and so on. So what I'm trying to show you here is that these are not good models of the Gregorian calendar. They are missing the possibility to represent some of the elements or the entities that you see in the problem domain. And when that happens, you end up doing things like this. Let's say a credit card where the expiration date is an array of integers, one integer for the year, one integer for the month. And then you start having things like this, or let's have the expiration date as a date. But when you have the expiration date as a date, what day number do you use for that expiration date? It should be the first day of the date of the date of the month, or it should be the last day of the month. So it's a problem, okay? And you can also do things like this: one integer for the year, one integer for the month, but at the end you end up having things like this. And the problem with this is that we are repeating and repeating code all the time. And that's because we are lacking abstraction, in this case, an abstraction to represent a month of year, okay? So just as a side comment, calendars are an excellent problem domain to model, yeah? And usually most of the programming languages have really bad models of the Gregorian calendar. They're really limited. And so my advice when you see these kind of things is to create your own models. If you're working with JavaScript and you need to model a month of a year, of a day of month, or a day of a week, do not use primitive objects. Just create the abstractions, create a model of the Gregorian calendar and do it, use it. It's going to help a lot, okay? We've done that in Smalltalk around 2005. We wrote a paper about it, and it's an interesting model where we use a metaphor of points in a line, and we represent the points as different entities of the Gregorian calendar, where you can zoom in and zoom out and go from different levels of elements of points in that line that represents the time. Okay, it's available, that paper, if you want to read it. Okay, there's a question. December 25th can be represented as a schedule, which represents every year. Well, a schedule for me is a different thing than a day of a month. Okay, a schedule is something like an agenda or something like that. It's not the same thing. Okay, so if I take the definition of a schedule, I would say no. Okay. And again, can we apply the same heuristic not only to objects in target domain, but also to events happening in a target domain and have corresponding programming language object representing event? Well, yeah, an event is an entity of a problem domain that you can represent with an object. So yeah, there is no problem. This heuristic can be applied on any problem domain. Yeah, that's right, Roberto. Yeah, you're right. So a really good example of a really bad model is Java util calendar. Okay, that's a really bad example of a really good example of bad modeling, bad design, starting from the name of the class. It's called calendar, but it's not. It doesn't represent calendars. It represents a timestamp, a date with a time. Yeah, calendars in Java are not a good example of good design. And any design problem or issue that you want to that you want to look for, you will find it in calendar. Okay, it's a good example of a bad model. So first heuristic, for each entity in the problem domain, there must be an object that represents it faithfully. And when I say an object, I'm not talking about a class. Sometimes you need a specific class and sometimes you don't. Okay, for example, if you had to represent a fraction knows is numerator and denominator, yeah, but you don't need a class numerator and denominator. The numerator and denominator of a fraction are numbers, are integers, so you can use that class already to represent numerators and denominators. But like I said, the computable model implies that the time passes. Okay, let's see. I think some models based on data, so that all problems of ORM is rising there. Well, yeah, when you have to persist your objects in a relational database, we're talking about two different paradigms: the object paradigm and the relational paradigm, that are not the same. That's why you have to translate from one to the other, and that's why we usually use an ORM to do that. But sometimes that translation from one paradigm to the other doesn't work as easily or as well as we expect. But my advice is to always start with the object model, and from the object model go to the relational model. Okay. Okay, so we have computable models that implies that time passes. That's why using analogies of the models we create with a map or with a plan of an architecture house or whatever are not good analogies, because in those models the time doesn't pass. That's an important and unique characteristic of software, and is the computable part, and the time passes. Okay, so it means, as you know, that when we represent a method, it means that the time will go, I don't know, for example, from the top to the bottom, okay? Just to say it easily. So if time passes in the model we create, one question we should ask ourselves is, since when should an object represent the entity of a problem domain? So let's see this example where I have a time class that has an hour, a minute, a second. This is a typical anemic class, okay, that has only getters and setters, yeah, no constructor at all. So when we want to use that class, we have to instantiate it, and then we have to tell it, okay, this is the hour, are the minutes, these are the seconds, and again, the same thing for another time, okay? So my question is, when the object now is really representing a time? Is it here where I instantiate in the class? Is it here when I say what is the hour, or when I say what is the second? So the thing is, because time passes, the moment where this object is really representing the hour 10 a.m. is after we set the second, okay, when the object is complete. Before this, the object now is is not really a time, it's a time in a potential time, okay? It's not really something that is representing a time, even though it is an instance of the time class, okay? So I can really use that object after the object is complete. Before that, it's not really what we want to represent. So in this case, if I have this assertion and I put it here, everything is going to compile, but if we run it, it's going to fail because those objects are not complete, okay? In this case, it's just giving an error because the assertion is failing, because numbers in Java are not objects, are data types, but if they were objects, for sure, we would get a null pointer exception or something like that. So what's the best way to do this? So the best way to model this is to have objects that every time you create them, you have to pass all the parameters that you need for that object to really represent that entity of the problem domain. So in this case, you have to, every time you instantiate time, you have to pass all the parameters that the time needs, the hour, the minute, the seconds. The good thing about this is not always that conceptually, from the moment that this object exists, is really representing a time. So conceptually, it's a good idea, it's a good design, okay? The object is representing an entity of the problem domain when the object appears in my model. But the other thing, the other interesting side effect of this is that when you change your model, the same model will help you to understand and to see the change. So for example, let's say I want to add a time zone to the time. Okay, so I want to have a time zone. Okay, so if we follow the heuristic that I didn't talk about, the heuristic that is object must be created complete. Yeah, if we follow that heuristic, it means that our constructor will have to receive the time zone as a parameter. Okay, so we should do something here. What I'm going to do, I'm going to refactor this and add a parameter with a change signature refactoring. I'm going to pass a time zone. I'm going to call it time zone. And the default value I'm going to use is new time zone. I don't know, let's say Argentina, that is GMT -3. Okay, just a default time zone. Going to refactor that. So now what I have is that every time I create a time, I have to pass the time zone. And now I can keep that time zone as instance variable. So the good thing about this is that if somebody else is using my class, yeah, when I create this new version of the class and he takes it from the repository, let's say, if he tries to compile with this new version of time, it won't compile because he will be using the constructor, previous constructor. And in this case, if you're in Java, it's not going to compile, okay? If you're in a dynamically typed language, it's going to fail if you run the test, okay? That's why it's so important with dynamically typed languages to have automated tests, because it allows you to replace some of the things that a compiler do in a statically typed language. But anyway, it's the same model that tells you that something has changed. And depending on how you made the change, you will notice that from the source code, and then you won't have to go and see documentation or read emails that nobody reads about, how the time class changed. So the good thing about this heuristic is not only that conceptually, when you have an object, it means that you have an entity, it represents an entity. It allows you also to manage the change in your design, okay? There's a lot of things to talk about this. Sadly, I don't have that much time. So basically, an object must represent the entity of a problem domain from the moment it exists. We should not have constructors with no parameter at all. We should always have one constructor that is the basic constructor to initialize an object when we create it, okay? And therefore, if we do that, the object will explicitly teach us what it needs to represent of that entity, and it also will help us changing the code when that class or model changes. I'm going to continue, and let's say later I will read the questions because there's not enough time, ironically. So is it enough to create complete objects? Is this heuristic enough? Well, the truth is not, because what happens if we want to create February 31st, 2024? Does February 31st, 2024 exist in the Gregorian calendar? Well, you know that the answer is no. There is no February 31st. February is up to 28th or 29th, not 31st. So if you have a model of the Gregorian calendar that allows you to create an object that does not represent anything on the problem domain, it's a bad model. For example, Java, okay, the calendar version of to represent the Gregorian calendar in Java allows you to create a date, which year is 2024, calendar is, the month is February, and the day number is 31st, and it doesn't say anything. It allows you to do that. But it's so smart that when you print it, it converts that day to March 2nd, 2024, okay? So these are the things that are not good from the modeling point of view, because you are allowing to have something that doesn't exist in reality. So let's not do that. Should not be possible to create February 31st, 2024, the same way it is not possible to have a fraction whose denominator is 0, and the same way it's not possible to create a credit card with an empty name or an empty number, and so on. Okay, so the heuristic, the third heuristic, is to only create valid objects. And when you do that, if you try to create, for example, February 31st, 2024, no, you cannot. So you throw an exception, and you cannot create that date in this case. So I was showing you the example of time here, and on this implementation of time, the hour, the minute, the seconds could be anything, any number. I could have a time with hour 25, pardon. sorry, or a minute 73, okay? And that doesn't make any sense. So to solve that, we should have a class that also validates every time you create a time, it validates how it is created. And this time, and this example, I create times using the static method add, where I pass the hour, the minutes, and the seconds, and I assert that those parameters are valid. In this case, I will assert that hour is between 0 and 23, that minute is between 0 and 59, and second is between 0 and 59, okay? So, and this way, every time I create a time, I will only have a valid time. And if this one of these assertions doesn't hold, so I will get an exception, and the model will tell me, will teach me that I'm not using time in the correct way. So I don't need to go to any to different documentation to know what are the valid numbers for an hour, for a minute, or a second. It's the same class, it's the same model that tells me how to use it, and every time I make a mistake, it will let me know. So an object must represent the entity from the moment it exists, but also it has to validate that that object is representing a real entity. And if not, it should fail immediately. The good thing about this is that we can use the same idea for user interfaces and any kind of interface, in fact. Let's say I have the class time that we just saw. If we use that time coming from a REST interface or a batch interface or a user interface, and we try to create an invalid time, because that class validates the creation of its instances, if we try to do it incorrectly, it will throw an exception. It doesn't matter from where I want to create that time. So what I'm going to show you now is I say this JavaScript web app, a really simple one that shows you a time, an invoice, and a customer. And for example, when you want to create, where is it? Let me see here. When you want to create a time, it asserts that the hour, the minutes, and the seconds are valid. Okay, so let's go there. I have to. So this is the React app. It's asking me for the first name, last name, the DNA in Argentina is the number that allows you to identify a person, and then from what time to what time that person work. So if I try to add this, it will show me, okay, the errors that, and these errors are the same errors that are thrown by the, in this case, for example, our assertion will throw this exception with this description. Well, it is a combination of Spanish and English. I don't know why. But let's say the hour must be an integer between 0 and 23. Let's say we make this change. So now if I try to add, it will show me that description as an error message. Okay. So what I'm trying to show you here is that when you follow this heuristic, you only have to have the validations in one place, and that's the domain model. And with that validation, you cover all the possible interfaces that you're going to have. User interfaces, batch interfaces, whatever, okay? So validating the objects in the business model allows having repeated code and maintainable validations, and also having those validations in the business model allows you to minimize the number of tests that verify the input errors that you can have. Good, so we have a good representation of entities, complete objects, valid objects. So one question that we can ask ourselves is, under this heuristic, does it make sense to use null or to use nil? And the answer is no. We shouldn't use null, we shouldn't use nil, because, you know, null is like a schizophrenic object. It's an object that means a lot of things, and it always, you know, gives you some problem. It will, you know, have some, it will appear in some part of the program. So when you use null or nil, you will get these kind of things. Yeah, the next number in the queue is null 95, or for example, null could not be found to confirm this payment, or the document null could not be opened. Yeah, things that for sure you know about. I remember my mother once calling me because she wanted to log in a banking system, and she got an error saying null is an invalid password, it's an invalid user, and she called me and said, who is null? Somebody is stolen my account. I had to explain her that that was not the problem. Anyway, so when we use null, okay, the thing is that we are using one object to represent many entities of the problem domain, and that's and at the end, if we do that in the model, we are losing information. Yeah, we're losing information that should be explicit, okay, in the model. I see that Alan.
Yeah, we have one raised hand. So Alan, hello.
So I see that he wrote something in the chat. Validation of object invariant is a simple heuristic, but this may not have as much practical value as processing such validation errors, which is more complex and important problem. I don't understand the question. I don't know, Alan, if you want to talk.
Alan, I can unmute you so you can talk to us if you want. Hello.
Alan? Well, we cannot hear you. So let me ask you, what do you mean by this may not have as much practical value as processing such validation error? That's the part I don't understand. So if you can explain that a little bit more, that will help me to answer your question, okay? Oh, I mean, what to do when we have such an error? Okay, if you have such an error from the model point of view, you just have to throw an exception. How that exception is handled, it will depend. I mean, you can show the error to the user, like I showed here, or if you are using a batch interface, you will log that you could not, I don't know, import a record and so on. So that's what you do when some validation doesn't hold. Okay, the idea is in the same way that physicists use measurement, for example, to represent measures, and you cannot have a speed based on liters per second. It's not a valid speed. Speed are only valid with a distance over time. So the same idea we are using to the models we write in with software. Okay, that's the idea.
Hello, can you hear me now?
Yes, we can hear you now, Alan.
Yeah, when it comes to representing stuff in databases, sometimes you just don't have the data, and to not capture what you have is far worse than capturing it and including a null. So what I see of nulls is they really have a place. They're not ideal, but sometimes that's the best you've got.
Well, yeah, that's a good point. What I suggest that's what I was going to show now is that if you don't have that data, so use an object that represents explicitly the absence of that data and not null, because null has completely mean different meanings. It's very difficult to understand when you see, for example, let's say a customer. Let's say a customer could have or could not have an address. So if you use null to represent the absence of an address, and then somebody forgets to check if the address is null, you will not know if that is a programming error or if somebody is using null correctly or if the customer was initialized correctly or not. Okay, because
in the case of the address, what you have is null would be I don't know, and blank would be they have no address. It's fairly straightforward. That convention.
Okay, that's a possibility. Okay, the problem with null is that every time you use it, you will have to put an if to be sure that you're not sending a message to null, okay, and getting a null pointer exception or does not understand or method missing and so on. Okay, so the heuristic that I'm presenting here is to represent the absence of that thing that you don't have with a polymorphic object. That's one solution. Let's go to the solution. Okay, you have different solutions not to use null. One of them is to use, for example, the null object pattern that represents the absence of that element, that entity, with an explicit object. Let's say define address and not define address. Not define address could be the null object for an address. Okay. Sometimes a null object is just an instance of the same class. For example, if you want to represent the null object of a string as an empty string, okay, you don't need a different class. But at the end, these are polymorphic objects, and that will allow you to avoid using the if message or syntax, depending on the language that you're programming. And the problem with if is that they are error prone. We usually forget to put the if, okay, when we have a null object, and that's why we have all these errors we have. Okay, but that's one solution. The other one is to use an explicit absent message. That's only possible when your programming language has full closures with non-local returns, like for example Ruby or Smalltalk. Okay, in that solution you use null, but you don't allow that null to go outside of your object. Okay, that's why you have messages like I want the address, but if it doesn't exist, execute this closure. Okay, and in doing so, you can encapsulate the fact that you're using null. And another solution, of course, is the optional. Okay, that's a solution from the programming language point of view, that you say that this variable can you make explicit that you can or you cannot reference null. Okay, that's the idea of the optional, or maybe there's a monad depending on the programming language. Yeah, that's the heuristic. You might not agree with me, Alan. That's fine. This is a heuristic that I've been using for a long time, and it really helps. It really helps, you know, to have a word without null. Okay, I don't know. It's difficult to imagine, but it's possible. Anyway, so why null exists? Null exists because before algol 68, you know, with algol 60 didn't have null and didn't have records, and Tony Hoare proposed a change to algol 60 to be included in algol 60A called record handling. If you read that paper, it's a very interesting paper. It shows you, you know, he's talking about records, but it's like talking about objects. So he talks about objects and records and classes. It's the first time in a paper in our profession where the class noun is used, and it's like, you know, reading about object-oriented programming, and then he says you have to have relationships between these records or objects, and when there is a relationship that is not complete, is partial, yeah, then you have this special value that is null, and that's how he created the concept of null. That's why most of the programming languages have null as a special value, and in the object-oriented paradigm we have null because Simula 67 used that idea. It was not called null, it was called known, the first object-oriented programming language, and that's why all the Smalltalk and C++ and so on have null. But it's interesting to listen to Tony Hoare, because in 2009 he gave a talk at the InfoQ called "Null: The $1 Billion Mistake," where he regrets, the idea of null, and he says, "I'm the one to complain about all the money that we lost in our profession because of the null references." It's very interesting to see. It's a simple talk, and in a moment he explained. He says that when he showed that idea to Dijkstra said, "This is not a good idea," and he uses a really funny example. I'm not gonna spoil that. So if you want to see it, you have to go and watch it. But anyway, Tony Hoare created this idea anyway, and that's why we have null. Okay. So like I said, there are many different solutions to avoid using null, and when to use each one depends on the type of the programming language and the system that you're writing. So if you're in a dynamically typed language and you're creating a new system, my advice is to use the explicit absent message or the null object pattern. If you're using a statically typed language, my advice to use the optional or the null object pattern. If the system already exists and something that could not be null and now it can be null, if you're in a dynamically typed language, I suggest you to use null object. It's going to be the easiest change. Or if not, the explicit absent message. And if you're in a statically typed language, again, the best solution is to use the null object. It's going to be the solution that is going to avoid making big changes in your system. And if not, use the optional. And if you have an existing system that breaks encapsulation all the time, everywhere, that is basically what we have currently in our profession, so you're doomed. And just if you're in a dynamically typed language, use explicit absent message and fix everything. Or if you're in a statically typed language, put an optional, make the compiler give you all the compile errors and fix everything. There is no other way to avoid using null. There's one last heuristic. I don't know how we're in the time. Where Diane, I think I don't have too much time. Do I? How much time?
If you personally have, I mean, if you don't have another meeting in a few minutes or something like that, we can still continue. It's not a problem.
Okay. Okay. Yeah, I do have time, so I will not rush too much. So given these heuristics, is also a good question to ask ourselves: when and how should an object change? Okay. If we have a complete object that is valid, how are we going to manage changing that object? Because if we change that object, I have to follow the heuristic that the new version of that object has to be valid. So how do I write those validations? Where do I write them? Yes. So here, this problem goes to a very, very long time ago, to the first problem the Greek philosophers thought about. And we have Heraclitus and Parmenides. And, Heraclitus said, no man dives into the same river twice. And Parmenides says, what is cannot be. It's very clear, like all philosophers. And, basically what they're talking about is the difference between mutable and immutable, in this case, objects, related to our profession. So we have to, when we follow these heuristics, one important question we have to ask ourselves is when an object must be mutable and when it must be immutable. Is it a technical question, or is it a conceptual one? So the answer is very simple, and as you may guess, it's a conceptual question. And an object must be mutable if the entity that is represented is mutable. Okay. So, for example, if you are representing, and an object must be immutable if the entity that is represented is immutable. So, for example, a date. Should a date be mutable or immutable? Well, if you think a little bit, dates don't change. You cannot change your idea of January 1st, 2024 with February 1st, 2024, because if you do that, you will lose a month of your life, okay? What you change is, for example, your date of birth, or I don't know, when you have to deliver something, you change the delivery date, but you don't change the date, okay? So dates are immutable. Fractions are immutable. Invoices, at least in Argentina, should be immutable. So if you are modeling those entities of the problem domain, your object should be immutable if that entity that you're representing is immutable. Okay, that's the heuristic. And of course, this, well, like I said, there are many objects that we can think as immutables, but something that we don't have to lose, sight of is that if something is mutable or immutable, sometimes depends on how we observe the problem domain. It's a problem of observation. There are many ways to understand a problem domain. There are many ways to understand reality. Yeah. So it's not always that easy to see that something is mutable or immutable. As a rule of thumb, something that you can think about of reality is that a sequence of events that generates immutable objects. That's one way to think about. That's, for example, what the functional programming paradigm does. Nothing changes, only new things are created. Okay, that's one way to solve the problem, but it's not the only one. Having immutable objects give us a lot of advantages. The first one is that we don't have to worry about the passage of time anymore. Yeah, we don't have to worry how an object will change, because when an object changes, the problem is how it impacts the other objects that is related to, that is coupled to, okay? So we don't have to worry about the consequences of giving away an object, for example. So let's say we have the customer, and the customer knows an address, has an address. And let's say we have some validations on that address. If the address is mutable and we give away that address to another object, that other object could change it, and then the validations that we run when creating the customer may become invalid. If the address is immutable, once you know that the customer is valid with that address, if you give away that address because they won't be able to change it, I don't have to worry about, about the customer to be valid or invalid. Okay, so having immutable objects, it's a good idea. Not everything can be immutable, but it allows you to simplify the representation of reality. But the truth is that there are things that change. Objects sometimes have to be mutable, for example, a collection, an array, dictionary. So how do we change? How do we manage that change? Well, I don't have too much time to explain that, to see how to solve this problem. But basically, the suggestion is to use atomic changes, to have one message that will synchronize with an instance of that object in one method only. So let's say customer has some validations. For example, the name cannot be empty, the address cannot be empty, or whatever. Yeah, so when you create an instance of a customer, you check that in the instant creation message. And let's say a customer has to be mutable. The name of a customer can change, or the address of the customer can change. So instead of providing setters for that, what you provide is a message called, for example, sync with or synchronize with, that will receive as parameter another customer. And what this method will do is will copy all the instance variables from that customer to itself. And you don't have to validate anything there, because that object that you receive as a parameter, you know it is valid because of the heuristic that you only create valid objects. So doing atomic changes is one way to solve the problem of, mutating objects. That is something that sometimes we do not worry about, and is a source of problems. There are more heuristics, but there is no time for that. For example, one important heuristic is do not break encapsulation. It's a very important one. We are used to break the encapsulation all the time. It's not a good idea. Also, there's another heuristic that is to model the architecture of the system in the system itself as a composition of systems. Yeah, that will help you to represent the architecture of the system in the system itself. So you will be able to reflect about the architecture of the system. And another heuristic that is really interesting is to use a metaphor to observe that reality, okay, and to provide like a vision, something concrete of what you are representing of the reality. Okay, metaphors are really useful when modeling. As a conclusion, these are the heuristic. For each entity of the program domain, there must be an object that represents it faithfully. Create complete objects, create valid objects. Do not use nil or null. Try to avoid that. Favor the use of immutable objects. And if you do that, you will be really happy programming and developing software. Like I said at the beginning, these are things that we talk about in our courses, about object-oriented design, about TDD, refactoring legacy code, and also refactoring, automatic refactoring per se. So this is the end, and now questions. Well, I see there are some questions in the chat. I don't know, Diana, do you want me to read those questions?
Yeah, please read these questions. We'll have them on recording. And guys, if you don't want to type your question, but still want to ask your question, you can push raise hand button and I'll unmute you then.
Cool. So I think the first one is immutable are measurements of real-world mutable objects. Okay, that's not a question, it's a statement, a good one. Thank you. Alexander is saying, each mutable object in real world can be represented with series of immutable programming language objects. Exactly, it's almost the same idea of what I said, but this can consume a lot of resources, of course, and this may not be a good, yeah, of course, that's right. Yeah, when you are designing software, you always have to make trade-off, between, the resources you have and how do you want to represent the program domain and so on. Yeah, that's a good point. Roberto says, can we use the value of the object as a criteria for deciding if it will be mutable or immutable, trying to preserve or maximize value? I don't quite understand what you mean by the value of the object. At least for me, the way I think about this is that if what you're representing is immutable, then your object should be immutable. That's the easiest way to see it, okay? Like I said, that depends on how you understand the reality, how you observe the program domain, okay? So, but this is a learning process. It's a process that we are all the time doing when we develop software. So, yeah. Alexander is asking where to find more information about metaphor heuristics. Well, I have a class about that, but it's in Spanish, so I think it won't work for you. Somebody that talked about metaphors was Kembeck on his first book about extreme programming. He talks about metaphors and how to use metaphors to understand reality and to model. But sadly, he removed that practice on the second version of the stream programming book. A good book about metaphors and how we as humans think with metaphor is a book called Metaphors We Live By, written by, well, I don't remember the name. It's an American philosopher that wrote many books about how we as humans use metaphors and analogies to think about things. For example, you can say, I went flying to the bank. Yeah, at least in Spanish, when you say that, it doesn't mean that you go flying. It means that you're going fast, that you want to go fast to the bank. Okay, so that's, we're using the metaphor there, that when you fly, you move, your speed is big, you know, that you move fast. Okay, so that's the idea behind using metaphors to make explicit or visible something that sometimes is invisible, like the software that we are writing. Okay, that's why, for example, a class, the class called file is called file, is because it's using the metaphor of a file in a desktop. Okay, or why we use the desktop idea in our computers, because the desktop idea and the folders and so on are based on the desktop that we have, the real desktop. Okay, those ideas are using a metaphor. Okay. Oh, I see that Ezekiel wrote the name of the author, George Lakoff. That's exactly. That's the name of the author.
Hernan, may I interrupt you for a second? Because
yeah.
I think that, yeah, a lot of people asking about the books, and it would be, and Yaroslav also proposed that, maybe you can add to your presentation a slide with a list of the books, podcast, video, I don't know. And I will like send this presentation, I don't know, maybe on Thursday with this additional slide with your recommendation. So everyone will have it.
Yeah, cool. Yeah, that's a good idea. Great. So Christina is asking, are there any specific programming languages or paradigms where these heuristics are particularly effective? Not really. You can use them on any programming language or paradigms. I used the object-oriented paradigm for these heuristics, but some of these ideas are applicable in a functional paradigm or any other, like the structured programming. But yeah, some programming languages will help you using them, and some of them will restrict you. But yeah, there is no specific one. Could you give all these authors? Yeah, I will. Okay, and yeah, I think those are all the questions.
Now we have another one from Matej.
Okay, yeah. So immutable objects can be composed of mutable ones. Not really. Okay, that wouldn't be possible, because that's one of the restrictions of immutable objects. If you have an immutable object, then the objects that compose that object should be immutable. Let's take, for example, a date. A date is composed by, let's say, the year number, the month number, and the day number. Well, numbers are immutable. Yeah, if a number would not be immutable, then you could change the year, and that would affect the date, and therefore the date would not be immutable. Okay, so yeah, immutable objects should be composed by immutable objects. If not, it's going to be impossible for that, to use that heuristic. The idea of synchronizing objects is for those objects that are mutable, okay? Objects that have to change. I hope I answer your question.